Good morning, everyone. Today's video is going to be on the topic of inequalities. We're calling this Inequalities Part 2. Our last video was Inequalities Part 1, which you've already watched. And the title is just Solving Inequalities. So let's take a look at our first example. I'm going to read it to you. You read along with me. And if I'm going too fast, you can just pause it. Mark is placing a classified ad in his city's newspaper to advertise his lawn care services. Ads cost 75 cents per word. So let's circle that. That's going to be 75 cents times, because we know per means multiply. So 75 cents for every word, which I think they're calling W eventually. He wants to spend no more than $25. Now you see why it's an inequality, because you see the no more than. Absolutely no more than 25 bucks for the ad. So letter A says, write an inequality describing the number of words W Mark could have. So let's first define our variable. So W is equal to the words in the ad. And we know, oh, not two D's. There we go, words in the ad. And we know that it costs 75 cents per word. So 0.75, 75 cents times the number of words in the ad can be no more than, so less than or equal to, $25. Now let's just talk about the equal to. No more than, well, $25 isn't more than $25. So we can go up to and including 25, but we have to stay under that or equal to it. So that would be an inequality describing it. Now letter B says solve the inequality and then answer how many words could Mark have in his ad. So I'm just going to bring the inequality down here. 0.75 W is less than or equal to $25. So can you think of what to do to solve for W? That's right. I feel like Blue's Clues. Divide by 0.75 and W less than or equal to. Grab your TI. And what do we have? I've got students in the room while I'm making this video, so bless you. 25 divided by 0.75. So 33.3 repeating words. Now this is where this is going to get interesting. You're never going to put an ad in a newspaper with a third of a word. So you have to be clever here. When you get a decimal and an inequality, if your words have to be less than or equal to 33 1/3 words, you're going to have to cut off the extra and bring it back down to the next integer underneath 33.3. Greatest integer function, everyone. So we're going to basically cut this off at W is less than or equal to 33. Because we can't go up to 34, that wouldn't work out. It would be too much money. In fact, if I do 0.75 times 34 words, see, I'm $25.50. But if I do 0.75 times 33 words, I stay under my $25 marker. So, Mark, let's answer this. So Mark can have 33 words or less in his ad to keep his cost under or equal to 25 bucks. Okay. Now that's more conceptual. That's more like of a real world problem. Now we're just going to do some skill building, solving inequality. So take a look at example 2. It says solve and graph. Okay, 2x minus 3 is less than 7 plus 3x. Okay, so we're going to draw, you know how we draw that line down through the equal sign to split our problem into two halves? We're going to do the same thing here right over this less than symbol, and then we're going to solve this just like we would solve an equation. So I'm going to bring my x's left, so I'm going to subtract 3x from both sides. It's going to cancel those out. That's going to give me negative x minus 3 is less than 7. And then I'm going to go ahead and add 3 to both sides. So that's going to cancel those out and give me negative x is less than 10. And we don't want negative x. That's like negative 1x. So we're going to divide by negative 1. And if you remember in our last video, we actually proved why when you divide by a negative in an inequality, you have to flip this symbol 180. So I'm not going to go over that again. I'm just going to answer this as x is, flip it, greater than 10 divided by negative 1 is negative 10. So to graph it on the number line, you're just going to go to negative 10. You are going to put an open circle there because we're not including negative 10. And we're going to shade all numbers bigger than that. That's this way. All of these answers are a solution. Now guys, listen, here's where it gets interesting. If you were to do a check, normally when we're solving an equation and you do a check, you have one solid answer for x, like x equals 6. In this inequality, you have an infinite number of answers you could check. In fact, you can put anything greater than negative 10 into your original problem for x, and it will be true. Anything here, see the red? Anything here is legit to plug in. So let's just choose something. Anything on this red, including numbers beyond this line, which we can't even see here. I don't know, for some reason 6 is popping out to me. Let's put x equals 6 in to our original inequality to check it. So it would look like this. 2 times 3 minus 3 should be less than 7 plus, why am I plugging 3 in? I just said 6. 2 times 6 minus 3 is less than 7 plus 3 times 6. Do the math. 2 times 6 is 12. 12 minus 3 is 9. Is that less than 7 plus 18, which is 25? 9 less than 25? Yes. So that's how you check it. All right, example 3, solve and graph. Same idea. 5 over 2a minus 7 is greater than 3. So let's draw that line. Let's go ahead and add 7. This is like getting rid of Uncle Joe. Add 7 to both sides. Cross it out. 5 over 2a is greater than 10. Now we're going to multiply by 2 on both sides so that these cancel. And I have 5a is greater than 20. That's 10 times 2. And now I divide by 5. A is greater than 4. All numbers greater than 4. All numbers greater than 4. So go to 4. Boom. Whole at 4, because we're not including it. We only want numbers bigger than it. Pick anything over here. Plug it into the original, and it should check out with a true statement for you. What's on the back? Okay, one more. Example 4, solve and graph. Negative 4s plus 5 is less than or equal to 25. So here's my line. Going to minus 5 from both sides. Negative 4s is less than or equal to 20. I'm going to divide by negative 4. Since I'm dividing by a negative, I'm flipping the symbol 180. And 20 divided by negative 4 is negative 5. So numbers, all numbers bigger than or equal to negative 5. So go to negative 5, fill in your dot, and shade all numbers greater than that. These are all solutions. You have a ton of them. There's not just one answer. There's a ton of answers. In fact, there's an infinite number of answers. And that's what your number line shows. So you can plug any of these into the original inequality and it will be true. Okay, so for mastery work, you're going to be given a worksheet. And on that worksheet and with a separate sheet of paper, you are going to do numbers 1 through 22. Stay organized as you always do. And hopefully this all made sense.